Hi guys. So as I talked about in the last video, this is just a chance for you guys to see how some of these different characteristics affect the way the graph looks. So these are just going to focus on a few specific features. Now, like I said, you guys will notice these will actually come back up in the Desmos activity that you're going to do, but I wanted to make sure I talked about how some of these things look. All right, so as we talked about, a vertical asymptote occurs when the denominator equals 0. Okay, because again, you cannot divide by 0, and as you get close to that point, your values are going to get either really, really big or really, really small. So on this first one, you'll notice this has an asymptote when x equals 2, because that's the factor that makes the bottom equal 0. Well, if I have two factors there at the bottom, there's going to be two vertical asymptotes. One of them is at -1, one of them is at +2. All right, but what your graph does in between those asymptotes could be different based on what the other features are. But notice again, this one has the asymptote at -2 and 5, just like you'd expect. The other thing we talked about is what a difference it makes if a factor is squared. So let's look at each of these. Notice at the asymptote, your graph is going in opposite directions in all of these cases. So at the asymptote, one end's going to positive infinity, the other end's going to negative infinity. So it doesn't matter which asymptote it is. So like here's an asymptote here at -1. One end is going down, one end's going up. At 2, one end is up, one end is down. It doesn't matter which one, but one end's doing one end's doing the other. When that factor is squared, let's look at this next one. There should be an asymptote at 0, because that's what makes the bottom equal 0. Because that factor is squared, both are going in the same direction. Same thing at the next one. The bottom it has an asymptote at 1, that factor is squared, so your graph is going in the same direction on both sides of that asymptote. It could be up, or it could be down, but the point is that they're going the same direction at that asymptote. All right, let's look at these last two examples. Where the squared factor is, okay, this factor is squared, so at 2, when I actually look at this, my graph is going to go in the same direction on both sides of that asymptote, either both up or both down. Whereas at -1, it's going to go in opposite directions. So notice again, there at 2, same direction on both sides, but at -1, it's opposite. Well, let's move where that squared factor is. Now it's in the same direction at -1, opposite directions at 2. So that's vertical asymptotes. Horizontal asymptotes, okay? It depends on the degree of the top and the degree of the bottom. If it's bottom heavy, your ends are approaching 0 in both of those cases. The middles can look different, but your ends are approaching 0. Same degree would divide those leading coefficients. So I've got right here, leading coefficient, I have 1/1, so y equals 1 is my horizontal asymptote. 8/4, y equals 2 is my horizontal asymptote. 6/3, y equals 2 is my horizontal asymptote. When that graph is top heavy, that's when you're going to have those slant asymptotes. So notice again, you're going towards either positive or negative infinity. Okay, again, looks a little weird, but your ends are going towards that where that slant asymptote is. And again, it could be opposite direction as well. And again, our graph can touch or cross a horizontal asymptote. All right, so it is possible to cross it and touch it, but the ends are still approaching that horizontal asymptote. Okay, so again, here it kind of does one of those things where it crosses over it, but the end is still going towards where that asymptote is. All right, and the last feature are the X-Intercepts. The X-Intercepts are really what kind of makes our graph do some of the different things that it does. Why sometimes it crosses or doesn't cross into certain places. So set the top equal to 0 to find X-Intercepts. So in this case, 2 does not equal 0. This graph does not have any X-Intercepts. Whereas the next one should have an X-Intercept at 1. And it does. Okay, that's why our graph looks the way that it does. If that X-Intercept was over here instead, so let's say that this, instead of x minus 1, let's say that this was x plus 7. Notice that flips the way your graph looks, because again, where that intercept is affects what your graph does. All right, next one, I should have an intercept at -3. Okay, I do. There's an intercept over here at -3. There are no intercepts in this middle area, which is why your graph does not cross anywhere in that middle area. All right, this case though, the intercept is in between those vertical asymptotes. Okay, that's why your graph is actually touching and doing kind of that little wiggle, almost looking like a cubic function in the middle there. So where the x-intercept is in relation to those points has an effect on the way your graph looks. So like, let's say this point was moved, instead of it at 1, 0, Let's say I had that intercept outside of that asymptote. Let's say I moved this all the way over to x minus 8. Entirely changes the way that graph looks. All right, this next graph has 2 x-intercepts. Both those intercepts occur outside of those vertical asymptotes, so notice this middle part doesn't touch. Again, 2 asymptotes here on the next one, but one of those intercepts is at -2, 0. It's in between those asymptotes. That's why your graph looks the way that it does. And then there's one more again. And then again, like we talked about, just like it was with polynomials, if a factor is squared, your graph is going to be tangent at that point. So notice at this intercept, your graph touches that point and then goes back in the same direction. It's going to do the same thing on this graph. That's the exact same graph. I don't know why I have that on there twice. Well, again, you can see it does the same thing. Again, at 0, okay, your graph is going to touch. This time, though, it's outside of the vertical asymptote. And maybe that's why I put this one on here. Maybe what I was trying to do is I was trying to move that outside so you guys can see how that affects it. So instead of 1, I'm going to pick an x-intercept that's going to be outside here. Let's just do x minus 6 so you guys can see. Oh, that changes our graph quite a bit because, again, now it's outside of where that vertical asymptote is. All right, and then again, it depends which factor is squared. Notice this graph has 2 intercepts. I've got one at 0, and I've got one at 1. And, oops, that's the point I meant to pick. There we go. Don't know why that one's listed. So, at 0, your graph touches. At 1, your graph crosses through. And that one's kind of hard to see. I probably put a little bit too much onto that one, but let's make that a different point. Let's make that like 6. There we go. So now you can see it crosses there, or touches there, and it crosses there. So just a lot of different ways that these graphs can look, a lot of different things. Again, if you're unsure where you're supposed to draw kind of these different curves and different parts of these rational functions, you can always pick a test point to help you figure out where this graph is positive and negative in certain regions. And that's kind of the no-fail way to figure out what your graph is going to look like. What I will challenge you guys to do, though, is to not just rely on a calculator or actually just plugging this into Desmos. Keep in mind you are going to need to be familiar with these graphs in future math classes when you don't have that calculator or Desmos with you. So don't just rely on graphing it now. It's going to hurt you in the long run.